Okay, so 2-3 there talks about, the very top talks about the definition of significant digits. And you've probably heard about this in chemistry, Sig Figs, right? So the reason we're going to talk about Sig Figs is because it tells you, as you're working through a problem, it tells you what to round to. Does that make sense? So instead of saying, hey, what should I round to all the time? If it's got 3 significant digits, then use 3 significant digits in your problem. Does that make sense? Now, I'm going to let you in on a little secret. I'm not a stickler for it, okay? Does that make sense? So if there's 3 significant figures in your problem and you give me 4, I'm okay with that. Does that make sense? All right, so what are significant digits? Significant digits is when you decide which ones are significant. So you count, I don't want this color. All digits from left to right, starting with the first non-zero digit on the left. So really, zeros only count as a significant digit if they're sandwiched between 2 numbers or they're at the end of the number. Does that make sense? Okay, so look there at number 1, part A, 0.034. How many significant digits is that? 2. Okay, we don't count those guys. The 3 and the 4 count. That guy's 2 significant digits. How about B? 0.0006. 1. Okay, now it's a tricky one. 113.09. That guy has 5. We count that 0 because he's in the middle. Does that make sense? Now, there's a little bit of debate with this bad boy. I should probably have this here. That makes it 4, right? But if there's no decimal point, then it would be 2. So I apologize, there's a typo, put the decimal point. So that guy is 4. Sorry. But like I said, I'm not a crazy stickler about it, okay? If you use the wrong significant digits in your problem, I'm not going to mark the whole thing wrong, okay? Like I said, it just gives us a clue on what to round to. China. Because right now, this guy just has 2 without having anything else. But when I put the decimal point in, then it says count those guys as well. Wyatt. Yeah, it makes it exactly 5,600. Thank you, Wyatt, for your help. Okay. This one, I could have rounded those 2 zeros from some other number. But when I put the decimal point in, it's like, no, it's exactly 5,600. Does that make sense? Yes. Okay, like I said, it just gives us something to help us. All right, so it says then solve the triangle to means find all the missing sides and all the missing angles. So if you look at number 2 there, in the problem, how many significant digits do you see in the problem? 2, right? This guy technically only has 1, but this guy has 2. So in my problem, I'm going to use 2 significant digits. Does that make sense? Now, if you go to 3, like I said, I won't count it wrong. All right, so first of all, it just says in right triangle ABC, A is 40 and C is 12. Solve the triangle. Holy cats, there's a lot missing, right? What should we do first? Okay, let's draw a triangle. We got a right triangle. Does it matter where I put A, B, and C? C is the right angle. Okay, what do we, that means that we know this guy is 90 degrees. That helps us a little bit. Does it matter where I put the other two? No, it certainly doesn't. But you need to know that across the triangle is little a, and across the triangle is little b, and across C, across the triangle, the hypotenuse is always little c. So that guy right there is 12. And angle A is 40. Okay, so they did give us some information. I'm going to plug in what I know here. Okay, what can we find easily? B, right? Angle B. What is angle B? 50. Okay, that made life a little bit better, right? Oh, we only have two things left to find. Now, you're going to use that sine, cosine, tangent stuff, and you're going to find the other two. Does it matter which angle you sit at? No, it's totally up to you. But there is some stuff that I would like you to write down, okay? I know a lot of you can do it in your head, but also I know some mistakes get made as well. So, I'm going to use what they gave me. Assuming I maybe I made a mistake when I subtracted. I'm going to go back and use what I'm given. So I'm going to sit here at angle A, and I'm going to say, okay, if I find A, then I'm going to want to look across my triangle. This guy would be opposite, and this guy would be hypotenuse. So what trig function do I want to use? Sine. Okay, so this is the stuff I want to see on your paper somewhere. The sine of my angle, the sine of 40 degrees, is equal to opposite, which is A, over hypotenuse, which is 12. Think about this as your key to partial credit. All right, how do I solve that guy?
You find out what sine of 40 is.
Okay, sine of 40 I can put in my calculator, right? Then what would I do?
Opposite over hypotenuse.
Multiply by 12, right? So I can take 12 times the sine of 40, and that'll give me A. You can do it all at once in your calculator if you want. Okay, so A is 7.7135. What technically, when I round it, should I put on my answer? 7.7, right? Because I want two significant digits. Now, technically, we've got lots of ways that we can find B, right? What's one way we could find B? Thomas?
The exact same way we just did.
The exact same way we just did, right? But would I use sine? No, you could, but you'd have to switch to the other angle, right? Or you could use cosine. We could also use Pythagorean Theorem, right? But I want you to realize that when you do that, sometimes you introduce rounding error. Okay, dokie? So just be careful. Like I said, but I'm not a stickler on Sig Figs, so it's totally up to you. I'm just going to go straight back to what I was given. So I'm going to say cosine now of 40 is equal to B over 12. So 12 times the cosine of 40, 9.1925, or 9.2. Okay, questions on that? Okay, let's go to 3. In right triangle ABC, A is 2.73 inches and B is 3.41 inches. Solve the triangle. Okay, how many sig figs are in my problem? 3. Okay, so just keep that in mind. Really, that's all I want you to know about sig figs is it just tells you what to round to. Okay? All right, so here we go. I'm going to draw a triangle. We know C is 90. Little a is 2.73 inches. Little b is 3.41 inches. What do you want to do first? Pythagorean Theorem, find little c. Okie dokie, here we go. 3.41 squared plus 2.73 squared is c squared. .0810, so then now I have to take the square root of that. What's C? 4.37, perfect. Okay, now what do you want to find? A. Okay, so if we find angle A, remember this guy's opposite, this is adjacent, this is hypotenuse. And I would really like to use the numbers they gave me. So I would like to use side A and B. So what trig function should I use? Tangent. Alright, so this is the part I want to see on your paper. The tangent of angle A is equal to opposite, or 2.73, divided by adjacent, or 3.41. Do I have an angle? No, I need the angle. So how am I going to type this guy in my calculator? Tangent to the -1, right? The arc function. Second tangent. And you can type the fraction in. That's okay. 2.73 divided by 3.41. So if we're, excuse me, if we're using 3 significant digits, what's angle A? 38.7 degrees. Okay, don't work too hard to find B. What do you want to do to find B? Add them, right? Or subtract them from 90. So 90 minus 30. 8.7, 51.3 degrees. Does that seem familiar from geometry? Remember all that? Bless you. All right. 2 more examples. Questions before? Yeah, Jillian.
So why did we run the
So why do we do 2 decimal points here and only 1 here? So we're just going to look at the number of significant digits. Okay, so 2.73 has 3 significant digits, and this guy would then have 3 there. Yeah. But like I said, Julian, if you did something different, if you gave me 2, gave me another decimal point here, I'm okay with that, really. Okay. Let's see if I can zoom out so I can see what it says. Number 4 says, a circle has its center at C and a radius of 18 inches long. If triangle ADC is a right triangle, find X and the distance from A to C. All right, so we know a few things. The radius is 18. So I know C to D is 18. It's hard to see, sorry. I didn't write that very well. But I also know that right here is 18 as well. What do you think we should do? What'd you say? We could find angle C. Do we have to though? No, we don't have to. It says find X and the distance from A to C. So really what we're looking at is this whole hypotenuse thing right here, right? So finding angle C doesn't hurt us, but it doesn't also get us anywhere, right? So my hypotenuse there is X plus 18. We could also give that guy a different length if you wanted. Like you could call the whole hypotenuse Z if you wanted, right? Do you like that better? Would you like to give him a different name for the whole hypotenuse? Does it matter? No. Okay. So here we go. If I'm sitting here at this angle right here, C to D, is that opposite, adjacent, or hypotenuse? Opposite. Which means A to C is my hypotenuse. So which trig function am I going to use? Sine. So the sine of 35 degrees is equal to opposite, which is 18, divided by X plus 18. What do you want to do to solve that guy? Okay, let's find the sine of 35. So he's 0.5736 equals 18 divided by X plus 18. Can I just cancel those 18s? No. Please don't do that. I've got a plus with him, right? How do I get variables out of denominators? Multiply them on both sides, right? So could I multiply both sides by X plus 18? Yeah. Okay, so he'll cancel there and I'll cancel there. So I have X plus 18 times 0.5736 equals 18. What do you want to do now? Divide by 0.57, divide that sine of 35 there. Distribute, what do you want to do? Divide. So x plus 18, which is the whole hypotenuse, is equal to 18 divided by the sine of 35. 31.3820. So the whole hypotenuse is how long? (31 inches, right? That's the whole hypotenuse. What's x? 31 minus 18, right? So 13 inches. Notice what happened, and I just want you to see it because I think some of you that I've had before, I showed you a trick. Bless you. If your variable's in the denominator, look at what we did. Right? My variable's in the denominator there. Pretty much what I did is I switched those two. So x plus 18 is equal to 18 divided by the sine of 35. Do you see that? So if your variable's in your denominator, we could have also, from this point right here, that pen doesn't work. That's the same thing as x plus 18 equals 18 divided by the sine of 35. Okay? That only works if your variable's in the denominator, though. Think about that as like a trick. Okay. Questions? Ready for the last one? All right. Number 5 says, in the figure, the distance from A to D is 32 feet. Using the given information, solve for x, which is the distance from D to C. Okay, well, if I look at this guy right here, this smaller triangle here, do I have enough information to solve for x? No, I really don't, right? I've got h and x. I don't have any other information. But what if I look at this big triangle here? So essentially what we have is we have two triangles, right? We've got the big one, and he's pink. That's really what I was trying to do. This guy's B, C, A, 38, H, and X plus 32. And then I have this smaller triangle here. What do both of those triangles have in common? H, right? They both have H in common. Because it sort of feels like right now I don't have enough to solve either one of those triangles. Okay, so let's see what we got. If I'm sitting here at A, and I wanted to write a trig function for this triangle, I have opposite and adjacent. So I'm going to say the tangent of 38 degrees is equal to opposite h over x plus 32. Now I'm going to try to do that again with this guy right here. So my blue triangle, if I take, again, the tangent, I have opposite and adjacent of 54 degrees is equal to h over x. So we just discovered they both have an h in common. So what if I solved each one of these guys for h? Do I care what h is? No, I don't. So as I rearrange this guy, x plus 32 times the tangent of 38 is equal to h, and x times the tangent of 54 is equal to h as well. Set them equal to each other, right? They're both equal to h, and I don't care what h is. I'm trying to figure out what x is. Okay, so here we go. X plus 32 times the tangent of 38 is equal to x times the tangent of 54. Now what do you want to do? Distribute, find out the tangent of 38 and the tangent of 54. Let's do it. Tangent of 38 is 0.7813. When we talked about with like logs, go to 4 decimal places while you're working and then round your answer to the correct Sig Figs. So 0.7813 times 32. So 0.7813x plus 25.0016 is equal to 1.3764x. .3764 minus 0.7813 gives me 25.0016 equal to, I'm out of room, 0.5951x. Ooh, that's hard, I'm sorry. So what's x, or d to c? Yep. So 42. Okay, questions on 2-3. So all you're doing is solving a bunch of triangles and finding all their missing parts. When it says solve the triangle, it means find all the angles and all the sides. Your homework on that section is page 87, 12 through 56 every fourth. Remember that means divisible by 4. So 12, 16, 20, 24, 28, 32. So every fourth goes pretty fast. Okay?